Good evening, everyone, and welcome to Embracing Change Without Breaking the World. It's awesome to see so many people passionate about API design.
Totally.
You know, it can be a bit of a dry subject, but hopefully you'll learn something here today. My name's Kyle Thompson, and this is Jim Flanagan, and we're both engineers with AWS. I work on the AWS SDK team, so we vend libraries that sit in front of AWS services, and Jim is on the cryptography service team. And those two roles are going to kind of come up a little bit as we're talking about how you change your APIs and libraries today. So there's really two sides to everything. So there's the service side, and Jim's kind of going to play the hat of service owner, and then there's the client side, the libraries that your customers use to actually talk to those web APIs, and I'm gonna kind of play that role. So AWS has, in the last decade, released 90 plus services, probably more than that after this week, and we regularly deploy several updates a week, often daily, sometimes multiple times daily, especially during reInvent. And we've kind of learned over the years that backwards compatibility is a big deal. It's something that's important. It helps customers who are using your APIs understand that this thing is stable. And you know, one of the core, well, there's one core premise of AWS is security and privacy is number one, but very closely after that is availability and reliability. And we kind of consider backwards compatibility to be part of that reliability promise. And we have kind of really strong feelings about that. We don't like breaking customers. And if we deploy a new service API that is backwards incompatible, or we deploy a new client version, which again is backwards incompatible, then we've broken our customers, and we consider that to be part of our reliability promise. So it's a big deal to us, and we take it very, very seriously. So who are we? Like, what gives us the right to kind of talk on this subject? Neither Jim nor myself are PhDs in API design. I'm not actually sure if that exists, but we're not. But who in the audience has heard the term bar raiser? Okay. So a bar raiser, just to give you a brief, is kind of an Amazonian term for someone whose role it is to improve the quality of something. Usually it's applied to hiring, so any person that gets interviewed has a bar raiser as part of their interview loop, and that person is kind of responsible for ensuring that everyone we hire into Amazon is raising the quality bar. But we have bar raisers for other things as well. And about 18 months ago, when kind of AWS's innovation was kind of escalating and we were releasing more and more changes, it kind of became obvious that we needed a mechanism to ensure that our APIs were high quality and consistent and continually improving. And so the API Review Bar Raiser group was formed. And it's a group of people who are passionate about designing APIs, and they have experience in this domain and publish a set of internal standards to service teams. And these service teams then use these standards when they're making changes to their APIs to kind of understand what we consider to be legal, backwards compatible, versus things that are potentially going to break customers. So there's really two core things that we want you to take away from this today. The first is kind of an understanding of what some of these rules are so that you can understand when you're interacting with AWS services what we might change and what we will not change or what we will try not to change. So that's kind of giving you some information about how to consume AWS services. And then the second side of it is when you're designing your own APIs and libraries, kind of using some of these techniques that we've learned over the years. So we're going to look at some definitions. What does backwards compatibility really mean? And then we're going to kind of go through an example service that we've used as kind of for the purposes of illustration. And then we're going to look at some kind of edge cases, so how to deal with validation and constraints, how to deal with exceptions. And then at the end, we've kind of distilled this down into a single slide with a set of rules for do's and don'ts. So with that, Jim, do you want to kind of take us through what our service is going to look like that we're going to talk about this afternoon?
You bet. Let's build up to defining that service. And before we do that, when we talk about evolving an API over time, obviously we need a starting point. And so this is our starting point. The orange box is our web service API. And the blue box is our client that we've developed to talk to that API. And so it's been in use for a while, and our customers are enjoying it. They're asking us for features. You'll see that soon. And so we release another version of this API, and we release another version of the client to talk to that API. People are still using the original client to talk to the original version of the API, and they're using the new client to talk to the new version of the API. So over time, we'll add more features, and we'll develop more clients. And we end up in this situation where we're running multiple versions of our API and maybe taking more resources than we care to. And we also, if there are issues that we need to fix, we have to figure out which versions of the service to fix them in and what versions of the client to redistribute to customers. And it becomes difficult to reason about if we're not caring about backwards compatibility, we're just releasing version after version and maintaining all of these versions of the service and the client. So we have a word in technology for this. It comes to us from the Italian. This means difficult to reason about, spaghetti. And you may see this a little bit in the future as well. So if we want to avoid that situation and not have multiple versions of our service, we can start out with our initial version of our service. And then instead of having V2, I represent this with API prime. This is just our API with new features. And if the API is backwards compatible and the client is forwards compatible, then the old client can talk to the new API and pretend that the new features don't exist. And then if someone wants to take advantage of the new features, they can just upgrade to the new client. So if that's the case, we only really need to maintain a single version of our service. And that becomes much more easy to work with, both for people who are consuming it and the people who are providing it. So what does the API do? An API manages resources. And so our toy API that we're going to work with today is going to be for managing travel. And so the core resource for that is going to be a trip. And a trip is going to have some data associated with it, a list of travelers, a description, and some more fields that we may add as we add features. And so we refer to the data structures that go back and forth in our API as shapes, and those shapes have members. And a service might manage multiple resources. So here's a flight that goes along with the trip, and those resources are often related in some way. So here's a containment relationship. So that's sort of the nouns of our service, what the service is, what the API is managing. So how do we go about managing that? We want some way to act on those resources. And so we call the way that we act on them operations. So here's the three operations that we're going to play with today: put trip, get trip, and list trips. And if you're of a more RESTful frame, this is the same three operations sort of cast into a RESTful path structure. Each operation is going to take some input and return some output. Either of those can be a scalar, a complex shape, or empty. So here I'm taking in a trip ID, which is a scalar integer, to get trip, and I return the trip that I'm currently on right now. This is trip 123 for me. And we call that the input shape, and then refer to the output as the output shape. Operations can also return error types, error shapes. So here, if I haven't set up trip 321, I ask for it, resource not found. So the resources are the things or the nouns that we operate on. We model them as shapes, which is structures with members. We have input shapes and output shapes, and backwards compatibility concerns can sometimes rely only on inputs and sometimes on outputs. And then we have the operations to operate on them. So what does it mean to change an API? What are the elements of the API that we're going to change? So when we talk about changing, here's our trip that we had before. It has the travelers and the description. And we want to add an origin field. Your customers have asked for that, and we're gonna add that.
Makes sense.
Yep. And so when we think about a client, an old client operating on this new shape, it doesn't know about origin. So if it's built in a forwards compatible manner, it can work with the backwards compatible API. And this is a change that's fine to make, right? Just to go through some changes that are not fine to make, if we remove a member from a shape, an old client trying to use that is going to have a bad time. So that's not going to fly. Similarly, if we rename a shape, that's the same as removing one and adding a different one. And also, if we change the type of a member, that's not going to be good, especially if in a language where it's compiled and it's expecting a certain type to come back over the wire. So that's a breaking change. So now we're going to take a look at how adding and removing things affects the client side of things.
Sure. So typically what happens at AWS when a service is launching or where they're adding a new feature, they'll come to my team, which is the SDK team, and say, hey, we want to bend clients to this. We want our customers to be able to interact with this service within their applications. And so a service team will come to us with a model. And this is the model that we're going to kind of play with today. And Jim's handed this over the wall to me. And we're going to look at some options for how we might actually write the code that represents this thing. So I'm going to use Java this afternoon for a few reasons. One, it's verbose, so hopefully even if you're not familiar with Java, you can kind of understand what's going on here because there's lots of description about what things are. And then the second is being a compiled language, it gives us some interesting properties when it comes to understanding a little bit about forwards compatible clients. So this might be a way that we would model the trip object. So we've got two properties, a list of strings and a description, and we just pass them into the constructor, and we have some getters and setters to get those things out. It's a nice immutable representation. I create it using the constructor, kind of a standard Java pattern. And this is something that Java developers would expect and would be familiar with. So who thinks that this is a good way to design our trip object? I can trick anyone.
No hands.
So there's a problem with this approach, and that is when we go to change our API, the service team has come to us, Jim's team has come to us and said, hey, our customers are asking for origin, we want to introduce origin, then we've got a little bit of a problem. So what we could potentially do is we can add that to the constructor as a new constructor argument. But the problem is that's going to break customers who are using the old constructor. And when we talk about forwards compatibility when it comes to clients, what I would expect as an engineer who's consuming a client is that if I were to upgrade to a new minor version of a library, it shouldn't break my existing code. I should just get new features. All my original code should still compile. So this is not the case here. So we can't do that. That's not going to fly. To use that terrible joke again. So what can we do? We can overload the constructor. So we'll just add origin as a second constructor now. So we've got one constructor that takes all three arguments, and the original constructor will now just delegate to that constructor and pass null for origin because we don't know what it is. And this is going to work because customers who are using the old version of the constructor will be able to continue to do so. And customers who want to take advantage of that origin feature or within the application, they want to have some areas where they use the origin feature, they can do that. So who thinks this is going to work? Is this a good approach? No one. Maybe I should flip the question around. Who thinks this is a terrible idea? So one of the things that you need to keep in mind here is that when we're operating at the scale of AWS, we can't handcraft these things. We need to be able to automatically generate the code for representing these models. And so as soon as we've done something like this, we need to understand the history, the evolution of our API, because we need to know what a shape used to look like, what it looks like in today's version, so we know what constructors to provide. And that's kind of getting messy, because we need to understand, we need to do diffs between versions, and it's really ugly. Of course, there's another option, which is that we can just do overloads of the constructor for every possible combination of the properties. You know, this seems fine, right?
I think they know what's coming.
So we're getting back into this technical term that Jim was talking about before when we go down this road, because customers now have to deal with many, many different constructors, trying to figure out which one's the right one. And there's actually an even bigger problem with this approach, and that is when we go to add the origin parameter, we can't do that, because in a compiled language, these two things have the same method signature. They both take a single string. You know, the compiler doesn't really care that one of them is called description and the other's called origin. It won't let you do this. So we can't do the generate every constructor approach. So if we're in a language where you could have default values on constructors, then you could just do that with putting your properties on constructors, and any new arguments that get added would just have some sort of sensible default, and customers who didn't care about it just wouldn't set that thing. But unfortunately, the examples that we're doing here are in Java. Java doesn't have this feature yet, and so we can't do that. We need to come up with a different approach. So let's do take two. We've got a trip object again, and it's got two properties, but we've got a no-args constructor. So we're not setting anything via the constructor, and we do it all through setters. And when I go to create one of these things, I new it up, and then I call set on it to set travelers, and then I call set on it to set the description. And you know, this allows me to add properties because I can kind of just, you know, customers who are using this thing won't use those setters. And it has another nice property as well, and that's in an IDE, you get the ability to kind of explore this API a little bit. So I can do new trip, I can call, you know, a dot something, and it will list out all of the properties on that object. And you know, that's a nice way to explore the API in code. As I mentioned, it's safe to add properties. We can do that. So who thinks this is a reasonable approach for modeling the trip object? A few hands? OK, cool. This is actually how the Java SDK does it today. So version 1 of the Java SDK that we vend out to customers does this approach today. And of course, there's getters on there. So there's some other nice properties about this, and that is that it follows what we call in Java land the bean spec, which is a way for libraries to kind of understand that this thing is a data object and how to get the data out of that object. Everything that's a property is going to have a setter and a getter, and I know how to kind of interact with those things. So libraries like Jackson can do serialization to JSON representations, for example, nice and easily. It's kind of a common pattern. That's something that, again, Java developers are going to expect. But there's a difference between this one and the very first example that we did. And that's that the models are mutable. And what I mean by that is I can change the properties of an individual instance at any time. And in concurrency land, we got multiple threads. Mutability can become a problem because basically the world can change under your feet. So what we really want was to go back to the very first option we had, which was a nice immutable structure. It wasn't going to change under me, and therefore it's thread safe, and we get a set of nice advantages with that approach. So how can we get something that's immutable but also forward compatible? So something that I can safely add properties to without breaking existing customers. So the builder pattern is the answer here. So this is really a combination of both approaches. So you have a builder object, which is the thing that you use to build up the state over time. So this is a mutable structure that you can set various properties on, and then you call build at the end, which is kind of the very last line of visible code there, and that's going to give you back a trip object. So the members of trip itself are final, and so this class is immutable. And the constructor is private. So as a library developer, I'm free to kind of add things in there. Customers shouldn't be using that constructor because they can't actually see it. So to use this thing as a customer is still fairly easy. We can kind of we can expose a static method on it to get a handle on that builder. Then you can set properties over time, and you call build. And it also has this nice kind of IDE exploration property that our setter option did as well. So I can kind of, once I get access to that builder, I can see the things that I can possibly set on it. Of course, adding properties to this thing is okay. That's the whole reason we went down this road, and so it'd be a bit silly if we couldn't do that. And we just add those properties to the builder and expose them on the trip object itself. So that's kind of how we're going to model Java-based objects in the new version of the Java SDK, which is currently in developer preview. So that's kind of two options for how you can go about modeling a complex type within Java, although this pattern can apply to other compiled languages as well. So now that we've talked a little bit about adding, and we know that adding is legal, I've had customers come to me, they're using the trip API, they're using the origin, and so what they really want is to add a destination as well.
Pretty important.
Makes sense, right? But the other thing they want is they want that to be a required field. They want it mandatory because a trip doesn't really make sense unless you're going somewhere. And I said I'd come to you and ask you if we could do that.
Sure, let's take a look at what that looks like. So when we talk about adding items which are required, we're talking about constraints on inputs. And so required is a constraint. And if you don't supply this on input, you're going to get a validation error from the API, right? You didn't supply the destination, which is required. So old clients will not be able to use this API anymore because they don't know about the required field. So we call these things like required constraints on inputs, and we model them in AWS as such. And so our models will say, hey, this is a required field. Other sorts of constraints that get validated are length constraints on strings, for example, ranges on integers and dates, and regular expressions. We can support all of those in AWS services. In general, expanding constraints is okay. So if you're going from a string that's 50 characters and now accepting a string that's 120 characters, that's perfectly fine. If you go the other way, by tightening constraints, it will break existing clients in the field because they were happy sending 120 character strings, and now they can't do that anymore. So another kind of constraint on strings we call an enumeration, and that's simply the values that would be accepted as input. So here we have our flight, we have the airline, which is a string, and we have the status, which is a flight status enumeration. And the enumeration will accept as input these 4 values. It starts as requested, it goes into processing, and will either become booked or rejected. And this is an enumeration that represents a life cycle. And so clients that are interested in this life cycle, what are they going to be doing? They're going to be polling to see eventually whether my flight got booked, and I'll take code path A, or my flight got rejected and take code path B. Right? So we call these 2 states, the ones that are at the end, terminal states.
So we've got customers using this API, and I've had customers come to me and they've said there's a couple of things they want out of this status that they think would be useful. The first is that rejected is like a really broad bucket, and a lot of the time it's either because some sort of error occurred during the booking process or for some other reason. What they really want is the ability to distinguish between an error rejection and some other kind of rejection. So, they really want another state to represent that. And then the other thing that they've kind of given us some feedback on is that it takes a long time to get from requested to processing. They don't really know what's going on inside there. So, are there some states in the middle there that would make sense that we can kind of give to customers?
Like a review state, for example.
Sure.
Okay. Well, do you want the bad news first or the good news?
Give me the bad news.
So let's imagine we've added a third terminal state, like we said. We've split rejected into rejected and error. So if we think about what an old client is doing, polling on this, if it's looking for booked or rejected and receives error, it's just going to poll forever. It's never going to accept that state. So that's a breaking change. So adding terminal states or adding forks in a workflow is something that will break clients that are in the field. The good news...
We can't have error.
Yep. The good news is if we want to insert a state between requested and processing, like review, a client that expects something to start at requested and expects it eventually to go through processing is not, if it is forward compatible, it's not going to be bothered by this extra review state, because it's eventually going to get to where it needs to be.
So we can have review, we can have the intermediate state, but we can't have a new terminal state.
Yep.
Okay?
So let's take a look at how clients deal with
Sure.
enumerations.
So yeah, so we've got this state model, we've got these enumerations, and it might be tempting to model an enumeration in the language construct for an enumeration. So Java's got an enum type, and many other languages have enum type constructs. So it's kind of tempting to use those, and I think it's what customers would expect, and it's obvious. So one way that we might want to model our flight status and our flight object in general is in this way. So we've got the airline string, of course, and then our enumeration to represent flight status exposed as an enumeration. So when I call get status, I get that enumeration type, and as a customer, I know that this thing is an enum, and I know that therefore it has some possible values to it. So who thinks this seems reasonable? Or is this a bad idea? Why is this a bad idea? So the problem happens where we want to introduce a new state. So when we go to add the review state, which is a perfectly legal and backwards compatible thing to do from an API point of view, when I receive that response from the service with that new state in it, and try and, in my SDK or in my client, try and deserialize that into this flight object, I'm going to have a bit of a problem because I don't know what review is, and so I can't create an enum to represent that. So that's not going to work. We can't expose things as an enum in this way. What can we do? So we can expose status as a string. On the wire, it's just a string. So maybe it's not so bad. It kind of makes sense that that we can expose this thing as a string. We'll still generate the enum property for our customers, but they'll need to go and find it and kind of do that parsing themselves and handle the error conditions that come with it. So again, who thinks this is a terrible idea? Oh, not too many people. That's good, because this is how the current version of the Java SDK does it. So that's my SDK. But we know this isn't great for a few reasons. We're kind of pushing the burden of handling the fact that new states might get introduced onto customers. And we really want to make life easy for customers. They're using these SDKs so that they can interact with services in a way that's simple, and they don't need to worry about kind of parsing to and from the wire protocol. So that's problem one. And problem two, which is potentially the bigger problem, is that by looking at the flight object itself, we talked before about how customers explore the API through the objects that are available to them. And if you were to look at this flight object, you might necessarily realize that status was something that was actually enumerated and that there were multiple known possible values. And so we've kind of got a bit of a discoverability problem here. So I think we can do better. So let's have another go at modeling our enumerations in code. So if we introduce a new kind of placeholder state into our enumerations, and in this case we've called it SDK unknown, we can use that to represent when the case where we've received a value from the service that this version of the client doesn't understand. And so what that gives us the ability to do then is to expose flight status as a top-level property again. And customers get all of the nice things that come with that. So I know by looking at the flight object that status is enumerated because it's right there on the type itself. And we're kind of handling that validation problem, or the case of us getting a type that the SDK doesn't understand on behalf of customers and sticking everything in the SDK unknown bucket. But there's one kind of wrinkle, and that is we've now lost the state if it's unknown. And so it kind of makes sense for us to expose a way for customers to be able to get at the underlying unknown value if they need it. Maybe they want to understand what things their client doesn't know so that they can decide whether they want to upgrade their client version to a new version and kind of take advantage of that property or that feature. So it's a little bit ugly because you've got two methods to represent the same property, but I think it gives us the best of both worlds in terms of discoverability and flexibility to be kind of forwards compatible. And so this allows customers to do code like this. I can do a switch on it because I know it's an enumeration, and I can look for specific statuses. And if I'm only actually looking for one state, then I don't ever really even need to care about the get status of string property. I just deal with this thing as an enumeration as if that was all I was worried about. So that's kind of what we're thinking in terms of modeling enumerations in code in the new version of the Java SDK. So while we're talking about validation, and an enumeration constraint is something that can be validated, I want to do a little aside on talking about client-side validation. So services expose models. Those models have those constraints kind of documented. So the fact that the traveler's list can't be empty, for example. The traveler's list must have one thing in it and only one thing in it. Or that a string might be a specific length. And so it's kind of tempting to apply those validations on the client side as well. Because then what we can do is we can save customers from having to make a wire call to the service to understand that the value that they've specified is not valid and it's not going to be accepted. So it's kind of tempting to be able to do this client-side validation. And then we also know, again, in our service definition, we know what properties of an API are required versus optional. And so we could potentially annotate things with this not null annotation here. And this kind of tells consumers of our API, like, hey, this thing's not going to be null. The little code snippet there on the right-hand side is a Kotlin snippet. I don't know if people have used Kotlin before, but Kotlin has some special handling for null. And it will actually expose things differently if it knows something's not going to be null versus something that could possibly be null. So now we've got a couple of problems if we implement this sort of validation. The first is we're limiting our ability for the client to be forward compatible. So let's take, for example, EC2 instance IDs. EC2 instance IDs originally were 8 characters in length. And I don't know if you know, EC2's become pretty popular. And so we've got, we came to a situation where we had to increase the length of that ID. And because we didn't do client-side validation, we were able to do that without too much pain. Had we been validating on the client side that an instance ID was only 8 characters, then we'd have a big problem because before we actually implemented this change, we'd have to do a big campaign to get all of our customers to upgrade their versions to kind of loosen that constraint. So that's the first kind of, I guess, gotcha about doing client-side validation. And the second one is we talked about the fact that loosening constraints is a legal thing to do. And one of the things that's included in that is a service could say that a field that was previously mandatory, was required, can actually become optional. So, hey, actually, we don't really need that thing anymore. So you can specify it if you want to, but you don't need to. We've loosened that constraint. But by doing that, if we were to use these annotations to kind of specify in the code what was required and what wasn't, then Kotlin, for example, is going to break. So you'll see it might be a little bit subtle, but on the right-hand side, on this one where it's annotated with not null, I can do description.length, and Kotlin doesn't need to do any special handling to understand this thing because it knows it's never going to be null. But now, once I've kind of upgraded my client version, I need to deal with this differently in Kotlin. I've got that question mark operator. So in Kotlin, you need to, at compile time, handle your null checking. So if we do this, we're going to break customers if we loosen these constraints. So this isn't a hard buster. This is not necessarily a don't do this ever, but it's kind of a warning. It's a dangerous area, and you need to understand why you might want to do that client-side validation and what the implications of it are. And as it happens, predominantly the AWS SDKs that we vend out do not do client-side validation, and we'll defer all of that validation to the service. So while we're talking about clients, I wanted to kind of wrap this up with one other type of compatibility that is specific to clients. And that is, so let's imagine that we have a trip client which represents all of the things that I can do in the trip API. And as Jim pointed out, we have 3 operations exposed. We've got a put trip, a get trip, and a get trips. And put trip in our service model doesn't return anything. It's blank. And so it makes sense from a Java point of view to have that as a void function. There's no return type there, so why would we model one? Customers can interact with that thing in this way. So I have my instance of a trip client. I call put trip. There's no response, so I can't assign it to anything. And then maybe I go and get that trip in a subsequent request. But down the line, the service team, Jim decides that we want to introduce a trip ID when you put a trip, because that makes sense. Customers want to be able to understand what the ID is of this thing that you've just created. And so now we have to change the return type of that operation. So who thinks this code is going to compile when we make this change? OK, this code actually will compile. And that is what we call source compatible. So at compile time, the fact that there's no return type or that there is a return type doesn't matter at the source level. However, there's a different type of compatibility that you need to be aware of, and that is what we call binary compatibility. So if we were to, instead of recompiling our application when we bring down the new version of the client, if we were just to take that client library and drop it straight into our existing application that had already been compiled, then at this point, this code is going to break. Because at the point that we try and call put trip, the bytecode that's been generated at compile time is looking for something with a specific signature, and the signature includes the original return type. And so what we're going to get is a no such method exception here. And so we can't do that. And so in the case of the Java SDK, we always have return types for operations, even if the return type at the moment is empty, because it leaves the door open for us to be able to add things in the future when there perhaps wasn't before. OK, so Jim, we've got this thing out in the wild. We're putting flights happily, and I've got customers coming to me and saying that they're getting validation errors because they're specifying the wrong airport code. And at the moment, validation errors just got a message on it. So in order for them to kind of figure that out and handle it, they need to parse it with a regex. And I thought it might be a good idea for us to introduce a new exception type that specifies that the error code is invalid. Do you think that's something we could potentially add? I think it's going to make it easier for customers.
In this case, I don't have any good news. So, and once again, I'm going to ask you to think from the point of view of the original client before we make this change. Let me ask you, are you going to make any changes to the put flight request when you make this change? So we're not going to add any more fields to that. So for the same input, a client that was always used to getting a validation error is now potentially going to get an unknown airport error. Actually, it's going to get that most of the time now. And depending on the sophistication of the application or what kind of exception handling they have, that could have lots of different effects, including crashing the application. So that's not necessarily something that we can do.
So existing customer or existing clients that are looking for that validation error, and we start throwing this new error, might be able to handle it very well. Okay.
Yep, but the reason I asked you about making changes to the put flight request is that there is a way to add new exceptions if you, at the same time, add a new feature that has to be exercised to get that new exception. So let's take a look at our put flight request. Before the change, we have an airline that's a string, and if that string isn't valid for whatever reason, it's too long, it's too short, we get a validation error. And so clients are used to that. And let's say that we add a date to our put flight request, and we want to get a different validation error for that. Well, that's totally fine because the customer has opted in to getting that new exception by exercising the new feature. But if they don't have to do anything new or novel to get that new exception, they're going to be, old clients are going to be broken.
So what about my customers who want to understand that the airport code they gave, or the airline that they gave was invalid? What can we do for them?
OK, so right now, we're just giving them a validation error.
Right.
And so if you get this validation error, what have you learned? Your request was bad, and you should feel bad. Right? That's all we can tell the customer. We might be able to put something in the exception message to help them differentiate why the exception was thrown, but that's not a terribly good idea because now you've extended the surface area of your API and your contract with your users to the string that's in your error message, and you have to be careful about changing that.
And my customers don't really like dealing with regexes anyway.
Right, exactly. So what we can do is we can treat error responses just like the normal data response. responses. We can add as much data to these responses as we want, and old clients can simply ignore it. They're not going to be broken. They're going to get the same exception. New clients can say, oh, there are these new members on the error. What is it? Well, the field, airport code, we can say airport code was invalid, and we can actually add another enumeration that says it was invalid because we didn't know what the airport was, so an unknown airport. So when I talked about forcing customers to parse exception strings, and sort of unintentionally adding to your surface area of your contract with the end user. We have discovered over the years that people will, if you don't give them the hooks to make decisions in code, they will find ways and behaviors. They'll latch onto the behaviors of your API, and they'll expect that. They'll expect the exception message to always be the same. And if you change it, not thinking that, oh, this was not part of the model, that's potentially going to break people. So some other ways that you can accidentally add undocumented features that people will figure out. Let's take a look at pagination. So for a list operation, we have a request that takes in optionally a next token, and the result actually has a next token in it. And the goal of that is we make our first list request. We get a list of items which may be incomplete, and if it is incomplete, we get a next token, page 2, and then we take that and we put it into the next request to get the second page. So it's pretty obvious how this token is composed. It's the word page with the page number I want. So what happens when developers start to get clever about what page they want, and you weren't really prepared for this in the implementation of your API, the results could be undefined, and that doesn't help anybody. It doesn't help your customers who are getting a timeout or a 500 exception from the service, and it doesn't help you. The other way that this causes issues for you as someone designing an API is it removes the flexibility to change what is in that token. So as you add features to your API, you may want to modify the shape of that token. And so we've updated our API to say, oh, this is the page range instead of the page number or the element range. But someone who's constructing that token by just slamming page and the page number they want, they're going to miss out on this new feature, and they're actually going to get an exception from the service that says, I don't know what to do with that token. So it constrains your ability to add features to your API. So what can you do? Oh, that's busted. What we recommend here is if you're passing data to the customer that they're going to send you back that has meaning, make it opaque. Make it so that they can't figure out what's in there. It may result in you having to maintain a little state on your service for a short amount of time, or do some other tricks, but it's really well worth it to not accidentally expose these things. So the other thing that you can do to constrain your ability to make backwards compatible changes to your API is to think like an object-oriented developer and try to reuse stuff as much as possible.
Hey, what are you saying?
A little dig. So here we have an update flight operation. It takes as input the flight shape, and it gives as output the flight shape. Seems perfectly reasonable. And so we want to make a change to the service that your customers are asking.
Yeah. So my customers are kind of polling on this flight status enumeration and waiting for the status to change. And what they really want to know is, did this thing get stuck? And what they're thinking is, can I figure out when the last time this thing changed? I think that might help them understand that progress is being made.
So a little bit of metadata for the API to help them do that. And that's not data that the end user owns. That's data that the service owns. The service is injecting that data in there. And so now if we think about our flight operation having, or our flight shape having that date field, last modified field, on input and output,
yeah,
can I set that?
Yeah, exactly.
Is that something I can set? So they might get a validation error saying, hey, I don't expect the date on input, or it might get ignored and they say, hey, I keep trying to update this, but it's just ignored and it still has the last update date that was in there. So what we generally recommend here is go crazy. Create a shape for every use. Don't try and share shapes within the input and output because things may not be appropriate in either one of those directions. Avoid sharing shapes across API operations and even across APIs. One thing you can do is you could use flight as part of the update flight request, or you could switch this around and have an update flight response that contained the metadata as well as a flight. So you can use containment to help with that.
Okay, so now that we've kind of looked at some of the things that you need to think about when designing both your API, the service API, and the client, it's time to kind of distill this down into a set of rules. And this is basically everything that we've just talked about in the last 45 minutes or so. So the good things on the left-hand side, these are things that won't break customers, they're backwards compatible. These are things that we here at AWS consider to be legal changes to an API. And so you can expect that when you're consuming AWS services, these things will happen. And then on the right-hand side are the don'ts. These are the illegal things. These are the bad things. These are things that, through our experience, is going to cause potential problems in the future when you start changing things. And so you won't see these changes come out of AWS services, and hopefully when you're designing your own APIs and libraries, then you can kind of take into account some of these rules as well. So with that, I think we've got a few minutes left for questions. There's some mics in the aisle, or if you don't want to do that, you can kind of come up to Jim and I a little bit later. We'll be just at the front. So thank you very much.